Right. Good morning, everybody. If you're on the West Coast, where I am, and good evening if you're out in the EU, where Lizzie is today. We will just get started in about a minute. I'll give folks a chance to kind of filter in. But we're really excited. We have a really great talk prepared for you today. Lizzie has given it at some really great conferences that she's been to. And so we're excited to hear what she has to say about online experimentation. But as you guys are filtering in, I'll just do a quick intro. My name is Maddie. I work on the marketing team here at Split. And this is my colleague, Lizzie. She is our resident data scientist. She is based out in the EU. I'm currently residing in Edinburgh right now. Or no, you're out in Berlin. I forgot. You made the move. Yeah, so as we go on, she'll be giving a really cool talk on experimentation today, and kind of what to look out for, how to do it successfully. And as we go through, we have some time reserved at the end for Q&A. So just make sure that you drop any questions that come up that you have. I have a few that have come in via email before for some folks that weren't able to join today. Hopefully, if you guys are, hello, I'm glad that you guys were able to make it. But if you are here and you have a question that you want us to go through, just drop it either into the chat box, which you can see here. Oops, that just went to panelists. You can see it here. Or you can drop it into the Q&A box as well, which will go to Lizzie and myself. And then we will go through them at the end. But without further ado, I guess we'll just kick it off. Hello, we are Split. We are a unified solution for feature flagging, feature monitoring, and experimentation as well. And speaking of experimentation, I am going to kick it off to my colleague, Lizzie, over here, who's going to give a wonderful talk on experimentation. So I'm just going to put myself on mute, take some notes of questions that come through, and I'm just going to let Lizzie take it away.
Awesome. Thanks, Maddie. Right. So hi, everyone. So I'm Lizzie. As Maddie said, I'm a data scientist here at Split. So as a data scientist, I spend some of my time trying to make sure that we present the most accurate and insightful results possible for experiments, and also trying to promote some experimentation best practices. So some of that you'll hear in this talk. Before joining Split, I was a data scientist at Skyscanner, working on their internal experimentation platform. And before that, I worked at Booking.com, so helping engineers and product managers run and interpret their experiments. Before I became a data scientist, I was actually an astrophysics researcher, so still using stats and data, but instead of experiments, using it to try and understand the universe better. But don't worry, so today this talk's all about experimentation. So the subtitle of this talk is, "With great power comes great responsibility." So you can think of this talk in two parts. So the first part is going to cover the power of experimentation. So what is it that makes experimentation such a valuable technique? And then the second part, we'll talk about some of the responsibilities of an experimenter. So by responsibility, I mean some best practices and some guidelines that you need to follow to make sure that you're maintaining that high level of accuracy and statistical rigor that experimentation can provide. So today I'm going to explain 4 things that make experimentation so powerful, but also 4 things that you need to keep in mind to make sure that you're harnessing all of that power and to make sure that you're getting the most out of your experiments as you can. But first, where does this need for experimentation come from? Well, if we think about how engineering has evolved over the last few decades, we've moved from yearly updates to software to now releasing and updating our software every single day, or even hundreds of times a day. So engineering teams are for sure moving way faster than ever before, and the frequency of deployments has just absolutely skyrocketed. But then this naturally begs the question, well, with all this extra speed, are we actually delivering more value to our customers, or are we just shipping shittier software faster? So experimentation gives us a way to actually answer that question. And with experimentation, we can change the way we work and the way that we define success. So instead of focusing on speed and focusing on how many features we deliver each quarter, we can start to focus instead on the actual value of the features, so the actual impact on the end users or the business of the work that we're doing. So rather than being focused on output, we can start to focus on outcome. And this is really important. So the hard truth is that it's actually not that common to get it right. So our expectations and our kind of predictions of how customers are going to respond to our features are often wrong. And Bing did this famous study where they measured how many of their features actually had the intended positive outcome. And they found that only 10 to 20% of them did. So this means that 80 to 90% of the time, or 8 or 9 times out of 10, the things they were working on weren't necessarily providing any value to the end users or to their business. And it's really important to normalize this reality. So to normalize the fact that we often miss the mark and our intuitions are often wrong, but also the fact that just because we don't get that kind of intended positive outcome, it isn't a failure as long as we've learned something in the process. So I'm sure you'll agree that it's always better to know how your customers are responding rather than just to blindly continue investing in an area which isn't necessarily very impactful. Cool. So before I go any further, I just want to clarify what we mean by online experimentation. Technically, what we mean is controlled experimentation, or you might hear it called randomized controlled trials. And this is just an experiment where everything is the same except for one particular variable, so one particular thing that you're controlling. So all the people in your experiment have exactly the same experience, except for one small thing, which you're going to control which version of that thing they see. And that way we can measure the impact of that one particular thing. And that one thing, it might be the color of a button, it might be an entirely new feature, a whole revamp of your site, or it might be some invisible backend change. But by controlling just that one thing, we're able to measure the impact of that. So I wanted to clarify the difference between online experimentation and controlled experimentation, because this technique has actually been around way before anything was online. And I like this fun fact because, as Maddie said, I used to live in Edinburgh. So apparently the first documented controlled experiment was actually run by a doctor from Edinburgh, and this was way back in the 1700s. So the story here goes that this doctor, he noticed that fewer sailors were dying on Mediterranean ships, fewer sailors were dying from scurvy. And so he hypothesized that the reason they weren't dying was because of their Mediterranean diet and because of the citrus. So he tested this by running a controlled experiment. And in this experiment, all he did was he picked one particular voyage and he gave half of the sailors on that voyage limes, and otherwise everyone just ate their normal diet. So here everything is the same except for that one variable, that one thing, and that was the limes. And so of course this was a great success. So it led to limes being added to the sailors' rations and then fewer sailors dying from scurvy. So experimentation can save lives. And it still does save lives today, but it can also be used in many, many more ways. So because we have so much more data now, we can start to test and measure the impact of even tiny changes. So this here is an example of one of those 10 to 20% of experiments that Bing ran, which did have a positive impact. And I think it's a great example because it's really surprising. So it's one of those things that at least I would say that definitely would never have guessed would have such an impact. So what they did is they changed the color of text and captions. So from the control colors on the left to the treatment colors on the right. So just this tiny kind of hardly noticeable change. And the impact was that it actually increased Bing's revenue by $10 million annually. So a huge change. And this is why experimentation is so powerful, because it can help us find those kind of unexpected gems. And this is one of the reasons why it's such a prevalent technique now. So your big tech companies, they're all running tens of thousands of experiments each year. So experimentation is all around us. So if you're a social media user, then you're probably going to be in a whole bunch of experiments without even realizing. But you don't need to be one of those big tech giants to use experimentation, because the way it works is actually pretty simple at a high level. So how it works in online experimentation is that when visitors come to your site or your product or your app, you just randomly assign them into a group. And then depending on which group they get assigned to, they'll see a slightly different experience. And so remember that slight difference in the experience is just that one thing that you're controlling. So you let it run for a while, you collect the data at the end, and then you decide which version works better. And I've kind of simplified that last step of deciding which version works better because there are some nuances which we'll get to in the second part. But fundamentally, experimentation is simple enough that anyone can do it and can start getting value out of it. Okay, but even though it's simple, it would still take some time and effort to set up an experiment. So maybe you ask, why should you bother? So why isn't it enough to just do your kind of standard analytics and track your metrics, but without running experiments? Well, there are plenty of reasons, but I think these are four of the most convincing arguments for why experimentation is absolutely worth it. Okay, so I'll go through them one by one. So firstly, experimentation is really powerful because it lets us remove the influence of external factors from the data. So there's always going to be many, many things changing in the world all the time. So that might be like news stories or current events, or it could be something just as simple as the weather. So maybe on a hot day, people tend to go outside and spend less time on their computer. So all these things are going to have some impact to your metrics. And this is why it's not really a good idea to say, release a feature today and then measure the impact by comparing yesterday's metrics to tomorrow's metrics. Because when you see a difference, there's no real way to tell whether that difference is because of the thing that you did, the thing that you changed, or whether it's because of one of the many other billions of things that are changing in the world all the time. So this is why experimentation is so valuable, because it helps us kind of remove the influence of all the other things, and it lets us know, it gives us a way to know that the difference that we see is really due to the thing that we changed. And that's because we can, with experimentation, we test both versions at the same time, so we're testing them in parallel. So everything else is the same. So all the things that are changing are impacting users in both groups. And this means, yeah, when we see a difference in the metrics, we know it's really due to the thing that we changed, unless it's due to noise. So this brings us to the second thing that makes experimentation really powerful. So with experimentation, we can distinguish between random noise and a real meaningful signal. So there's always going to be randomness and noise in this kind of data. So even in the hypothetical scenario where nothing is changing in the world, you'll still see some fluctuations in your metrics. And that's just because the users that will come to your site are going to be different on different days. So yeah, they're always going to slightly fluctuate just due to this noise. But experimentation gives us a way to distinguish between noise and a real signal, because rather than just measuring, say, one thing like the metric value, just the metric value, experimentation also measures like the variance in the metric, and it will estimate the shape of the distribution of the metric. And then the statistics of experimentation give us a way to kind of estimate what's a likely range for that noise. So then when we do see a difference, we can use the statistics to say, is that likely to see given the noise, or is it really a real meaningful signal? And so this is where the term statistically significant comes in. So it's a term you hear a lot in the context of experimentation. And basically it means that the result that you see, the thing that you've measured, is really unlikely to have occurred just due to chance. So it's like a stamp of confidence that what you're seeing is really because of what you did and not noise. So reaching significance can kind of make the difference between celebrating a successful feature or going back to the drawing board and having to look for other ways to have an impact. Cool. So then the third thing that makes experimentation really powerful is that it lets us remove human biases from the decision-making process. So there's a huge number of cognitive biases that impact how we all think, how we process data, and how we make decisions. For example, there's a human tendency to see patterns in data when they're not there, or kind of the recency bias, which means that we kind of focus on and overweight the importance of information that we've learned recently. And we all have a human tendency to focus on data which supports what we already believe or what we hope to be true. But by running a scientific and a tightly controlled experiment, we're able to make better decisions because we can cut these human biases out of the equation and make sure that we're really following the data. So in this way, experimentation can kind of let us hear the voice of the users more clearly and without being influenced by our own inherent desire to be right. Of course, and the fourth thing that I want to mention that makes experimentation super powerful is that it lets us rapidly detect issues when they arise. But also, it lets us pinpoint what's causing those issues. So because experimentation measures things on a feature-by-feature basis, it means that we can kind of drill down into just the relevant segments. So we can see data just for users who actually saw a particular feature, and then compare that to a statistically identical set of users who didn't see that feature, who saw the original version of that feature. And in this way, experimentation gives us a much more kind of precise and informative view. So this image here, it depicts one particular example scenario, but seen through two different setups. So one of the setups has experimentation, and that's on the right, and then the setup on the left doesn't have experimentation. And this example scenario here is that we've just released 3 different features, and we're releasing them cautiously, so only 5% of users see each of these new features. And it just so happens that one of the features, that's the feature 2, the one in the purple box, this has some bug, which causes 40% of users to see an exception. So maybe this is because there's one particular browser that wasn't tested properly, and anyone that visits your feature on that browser gets an error. Well, if you were looking globally, so if you're looking just at your total number of users and total number of exceptions, for example, maybe through an APM tool or an analytics tool, then you'd be in this left-hand panel. And in this scenario, in this setup, you'd see just that 2% of users got an exception. So when you see that, well, you don't really know if that's a meaningful thing, if it's a real problem, or if it's just noise, and you're probably not going to prioritize looking into that straight away. And also, when you do look into it, you're not going to know where to start looking because you've got 3 features and you don't know which one's causing it. But on the other hand, if you were in the right panel and you were releasing all your features behind an experiment, then you'd immediately see that 40% of users are seeing an exception when they visit feature 2. So you immediately know this is it's a real big problem. You know which feature is causing it. So you can go and flip that kill switch and kill it straight away and go to debug. And you don't have to roll back all of your recent changes. So releasing things behind an experiment it reduces the time to resolution, and it gives us sort of safety and confidence in our deployments. Cool. So there were the 4 pillars of power there. But so now we're on to the responsibility part. And that's because with all this great power comes some great responsibilities. So experimentation can give us amazing statistical rigor and accuracy, and it gives us some really strong and quantitative claims on things like how confident we can be and what are the chances of drawing an incorrect conclusion. But there are certain best practices and things that you need to keep in mind in order to maintain that rigor and accuracy. So these best practices make up the responsibility part of this talk. And I picked these 4 to talk about today. There are plenty more, but I think these are some of the big ones. So if you're doing these 4, then you're probably already running a really great and trustworthy experimentation program. Cool, so I'll go through them one by one again. So the first one, you should really start with a hypothesis and also make sure that you stick to that hypothesis. And so a hypothesis is basically like a prediction or a statement that your experimentation aims to support or disprove. So it might include the thinking that drove that experiment, and the decision criteria that's going to help you decide what the next step should be. And ideally, a hypothesis is going to be clear, concise, understandable, and testable. And by testable, I mean that the data that your experiment gathers needs to be able to support or disprove that hypothesis. So it's really important to define that hypothesis up front, and that's before you've seen any of the data coming in. And this is because that way we can remove those human biases that we talked about. Because as soon as you let the data start influencing your hypothesis and the way you're thinking, then you're losing some of that scientific rigor, and you can't have as much confidence in your conclusions. And this saying encapsulates that issue a lot. So if you torture the data long enough, it will confess to anything. And this means that if you go looking for a signal, so if you go slicing and dicing the data into different segments, looking at different things, and you try and find something interesting, eventually you will find something, but you can't have the same confidence in that if you strayed from that original hypothesis. So this XKCD comic is an example of doing this irresponsibly. So here in this comic, the scientists are testing the hypothesis that jelly beans cause acne. So they use an experiment to do this. And the original result is that it doesn't support the hypothesis. So they find no signal that jelly beans cause acne. But they're not really happy with that disappointing result. So then they stray away from the original hypothesis, and they go and they start to measure all the different colors of jelly beans. So they're slicing and dicing, and they're checking if there's a signal for all the different colors of jelly beans. Eventually, they find that there is some link between green jelly beans and acne. But at this point, they've then tested 20 different colors. So they've basically tested 20 different hypotheses. And when they reach this result about green jelly beans, they can't have the same confidence in their result. So the responsible thing to do here would actually be to rerun an experiment. And this time, green jelly beans would be called out in that new hypothesis. Cool. So the second thing to keep in mind when you're running an experiment is that it's really worth investing time in choosing the right metrics, because having good metrics can change how much insight and value you can get out of your experiment. And there's no perfect metric for all scenarios, so it would depend on your business and what exactly you're testing. But these are some common characteristics of a good metric. So the first one is that a good metric is meaningful. And this means that it's directly capturing some business value or some customer satisfaction. So something that you really care about. So for example, measuring how many people expand an item description is a really interesting thing, but it's probably not the best thing to have as your key metric, your primary metric, because it's not directly measuring real business value. A second characteristic of a good metric is that it's sensitive. And this one is a really hard one because you can't really change the sensitivity of a metric. So it's not always possible to have a sensitive metric. And by sensitive, I mean that the metric should move and respond to small changes in behavior. So an example of a not particularly sensitive metric could be like lifetime value or churn rate. So these things are super valuable or meaningful metrics, but they're not very sensitive because they're slow moving and they're kind of a low signal metric. So the third characteristic of a good metric is that it should be directional. And what this means is that when a metric moves up or down, you should know instantly whether that's a good or a bad thing for your business. So an example of a not directional metric could be purchases per session. So if that goes down, I mean, it could be that the purchases have gone down, but it could also be that the number of sessions has gone up. So maybe your users are really enjoying your content and they're coming back and they're having more sessions. So in this way, this is not a directional metric because you can't immediately tell whether it's a good or bad thing. So it's not a good idea to use that metric as a key metric. And then the final characteristic of a good metric is that it needs to be understandable, because at the end of the day, you'll need to kind of convey your results to stakeholders and to business execs. So ideally, anyone in the business should be able to understand what your metric represents. Cool. So this is an example of, again, an irresponsible experiment. So here, this is a Chinese shoe company. It's an ad that a Chinese shoe company ran on Instagram. And in this ad, you can see there's an image of a fake hair there. So the thinking is that people are scrolling through Instagram on their phones. They see this, they think they've got a real hair on their phone, and they go to swipe it away with their thumb. Well, this is an example of gaming the system. So of kind of aiming for a significant positive experiment, getting a movement in the metric, but it's not aiming for real business value. So here they're tricking people to come to their site, but I'm assuming their shoe sales didn't go up, and it's not really a responsibly run experiment. Okay, so still on the topic of metrics, beware of measuring just one metric. So it's a good idea to keep an eye on what's happening below the surface. So measure things like latency and exception rates. And these kind of guardrail metrics, they don't necessarily need to tie back to business value directly, but it's important just to keep an eye on what's going on to make sure that they're not degrading in the pursuit of that one key metric. But at the same time, beware of measuring too many metrics. So this is because every comparison you make, that could be different metrics you're testing or different treatments, different versions of your new feature, or different segments or cohorts of users. All these things are comparisons. And every time you do a comparison, it brings its own chance of being a false positive. So the more things you test, the more comparisons you make, the higher the chances that you'll see a false positive. That means the higher the chances of getting a false conclusion. And it really does add up. So this graph here shows how the chance of seeing a false positive increases as you start to measure more metrics. And for this chart, we've assumed a kind of standard 95% confidence level. So this means when you're measuring just one metric, you have a 5% chance of seeing a false positive. But if you measure 15 metrics, you actually end up with over 50% chance of getting a false positive. So what this means is that if you're measuring 15 metrics with every experiment, and even if all of the things you are testing are absolute rubbish and having no impact to your users at all, you're still going to see a significant result 50% of the time. So it makes it really hard to interpret when a significant result is meaningful or not. But luckily, there are safe ways to measure many metrics. So one of the things you can do is you can use a stricter confidence level. So you can do this kind of manually, or you can do it algorithmically. So at Split, we have a multiple comparison corrections feature, which kind of optimally and automatically adjust your confidence level depending on how many metrics you have in order to maintain that overall level of the false positive rate. If you don't want to go down that road, you can also just retest any of those metrics that look significant but that weren't your primary metric. So those metrics that weren't part of your original hypothesis. So this is like in that green jelly bin example with the XKCD comic. If you see a significant result that you didn't expect, the best practice is always to rerun the test, but this time that unexpected result needs to be the key part of your hypothesis. Okay, so a third thing to keep in mind when you're running experiments is that you need to make sure you've collected enough data before you go and draw your conclusions. And this works in two ways. So the first way is to do with seasonality and business cycles. So here, this image is showing yearly seasonality for web searches for swimsuit and ski jacket. So as you'd expect, you have much higher searches for a swimsuit in the summer and higher searches for ski jacket in the winter. So there's a really clear yearly seasonality. But as well as yearly seasonality, you're also very likely to have a daily seasonality or weekly seasonality. And that's because people that come to your site at 9 a.m. are going to be very different to the people that come at 2 a.m. And people that come on weekdays are probably going to be different people than those that come on weekends. And so because of this, it's not really safe to run a test, say, from Monday to Friday, and then maybe that test is really positive and it looks great. Well, you shouldn't just draw your conclusions there and maybe put it live, because it could be that the users that will come on the weekend actually hate what you've changed, and the overall result could be negative. So before you draw your conclusions, make sure you've got like a representative sample and you've got some full sets of business cycles. And the other way that collecting enough data applies is that you need to understand the sensitivity of your experiment. So experimentation isn't magic, so there's always some limits to what your experiment is able to detect. So any particular metric in a particular experiment will have a minimum likely detectable effect. And this is the smallest change that you can reasonably expect to be able to see. And if you test with a larger sample size, so usually if you run that experiment for longer, then you're able to detect smaller differences. So you're getting a more sensitive experiment. And it's really important to understand that sensitivity, because just because you don't reach statistical significance doesn't mean that you had no impact. So to be able to interpret those inconclusive metrics, you need to understand the sensitivity of your metric. So you could, for example, if the minimum likely detectable effect was, say, 10%, what this means is that we can be pretty confident there was no impacts bigger than 10%, but we can't really say anything about any potential impacts smaller than 10%. So if you get an inconclusive metric with a sensitivity of 10%, you could have reduced it by 9% or increased it by 9%, you just don't know. So it's really important to understand what the sensitivity is before you try and interpret inconclusive results. Okay, so then the last responsibility of an experimenter, I think, is the most fun one, and that's that you need to take action on the data. So make sure you've interpreted it correctly and you're taking the right next steps. Of course, we already talked about significance, so there are kind of three main results that you might get for your key metric, that metric that's called out in the hypothesis. The first one is a statistically significant metric that's moved in the desired direction. Well, firstly, go ahead and celebrate. That's great. You've achieved what you hope to achieve. And then you probably want to continue ramping up this winning experience to make sure that you maximize its value. And then maybe you want to see if you can kind of apply these learnings to other parts of your product or to other segments of users. On the other hand, if you get a significant metric that's moved in the undesired direction, then you probably want to kill that experiment so no more users see that undesired version. And then maybe go to look into the data, see if you can get any ideas, any insights as to what might be going wrong. So why are users not responding the way you expected to? And then once you've done that, maybe you want to re-implement it, see if you can find a new way that might have a different outcome. And finally, if you get that inconclusive result, so you don't reach statistical significance, remember, firstly, you need to understand the sensitivity, so understand what range of impacts you've ruled out and what range of impacts you don't really know about. And then if you're often seeing these inconclusive results, then you might want to start thinking about testing bigger and bolder changes, so ones that are more likely to have a bigger impact to your users and then are more likely to reach statistical significance. Okay, so that's the 4 things that make experimentation so powerful and the 4 things to keep in mind to make sure you're harnessing all the power. So I just want to wrap up this talk with a few key takeaways. The first takeaway, experimentation gives us a way to measure real value. So it lets us really find out how our users are responding to the features and to find out if we're really achieving those original goals. And it gives us a way to focus on the outcome of our work rather than just the output of our teams. Second takeaway, experimentation can give us a lot of safety and confidence when we're deploying, because we can measure things on a feature by feature basis. And we can have a much more kind of precise and informative view of what's going on when we deploy things. Final takeaway, with this great power does come some responsibilities. So you need to follow these best practices and these guidelines to make sure that you're maintaining that statistical rigor and accuracy and that you're getting the most insightful results possible. That's all I've got, so thanks a lot. I'm open for any questions.
That was awesome. Thank you, Lizzie. I have got a few questions that came in as we were talking. I will let folks, just as we go through them, just another reminder, drop them into either the Q&A box or into the chat channel. But I'll just start going through in the order that they came through. So one question that we received was, you talk a lot about not being distracted by the data. What is the right number of metrics to look at when you're experimenting?
Yeah, so I know that was some tricky advice given there, kind of conflicting advice of don't just measure one thing, but don't measure too many things. Yeah, there's no perfect number of metrics. It's always kind of a balance. So the more metrics you do test, obviously the kind of wider view you have and the more information you're getting, but you also have that higher chance of getting a false positive. So if you're using one of these multiple comparison correction techniques, the way it works is that you can maintain the desired level of confidence, but you lose some of that sensitivity. So it's always a balance between sensitivity and getting a wider overview of what's going on. So no real answer. It depends on whether you value more information or more accuracy.
Makes perfect sense. Another question. Will this recording be sent to participants afterwards? Yes, the recording and slides will be sent out to everybody afterwards. So you can share the recording and the slides amongst your colleagues or keep them for yourself. We don't judge. Thank you for asking and reminding me to tell everybody. Another question we got is, what is your philosophy for when the data does not have significant change?
Yeah, that's always kind of a disappointing result, I think, for a lot of people. I'd say philosophy would be, don't take that as a failure, firstly. So you have some data and you've learned something. So you haven't seen the impact that you expected, but that's also a learning. So then the best thing to do would be to dig into the data and see if you can see if people are responding the way you expected them to. So maybe people aren't visiting that feature, or maybe they are, but it's just not driving them to change their journey in the way that you expected. So the philosophy, yeah, the main point would be, don't take it as a failure. If you run a well-designed experiment, then that's still a success and you've learned something.
Great. Another question we got. For an experiment with low daily volumes, would you recommend lowering the confidence level needed to call a result in good time, or let the experiment run for more time at a strict confidence level?
Yeah, so that's again another one that comes down to just your priorities. So there's no right answer there. It's from the kind of a statistical point of view, if you're asking a data scientist, then run it for longer. Like, it's always going to be get as much data as you can, have the most accuracy as possible. But then you always have the kind of competing view of product manager, whoever's running the team, that wants to keep that velocity up. So I think if it comes down to either like not running it as an experiment or running it at a lower confidence level, for sure run it, but have a lower confidence level. So yeah, I understand that it's a trade-off, and that's a decision you need to make about the priorities of velocity versus accuracy.
Great. Well, I think that wraps up all of our questions for today. But thank you so much, Lizzie, for giving this really great talk. Thank you, everybody, for joining today. Don't forget to follow Lizzie on Twitter. She is at Lizzie Eardley. If you have any questions, you can send her an email at lizzie.eardley@split.io. And then I will be following up. You'll be hearing from me with the recording sometime tomorrow, and I'll be sharing out the slides as well with some nice little bullet points of Lizzie's takeaways so that you can share with your colleagues, share with your friends in the same space. But thank you, everybody, for joining. Thank you, Lizzie, and we will see you all next time for our next webinar. Bye, everybody.
Bye.